Alright, we're back. Yo, Steven, we have to start recording our math videos soon, you know what I mean? We have to...
No,
Steven.
No. No.
Steven,
No.
are you trying to improve your rap game again? Steven, no rapping. We have to do a math video.
No flex. No.
So that was weird. Big Steve loves his rap game.
Thanks, Dave.
Welcome back to another episode of Hail Jesse.
Thanks, Dave.
It is King Jesse here featuring my partner,
Thanks, Dave.
Big Steve. That's it, you heard him. The one and only. Now we are here today to show you
Thanks, Dave.
one-to-one property of exponential functions. Right there, ladies and gentlemen. In lesson 3.2, exponential functions were shown to be one-to-one. And if you remember from lesson 1 to 7, that if a function f is one-to-one, no y value is matched with more than one x value. And that is shown by f of a equals f of b, if and only if a equals b. Fair enough. This leads us to the following one-to-one property of exponential functions. Big Steve, take it away.
Key concepts. One-to-one property of exponential functions. Alright. For b is greater than 0 and b does not equal 1, b to the x power equals b to the y power. If and only if x equals y.
Bam.
Examples. If 3 to the x power equals 3 to the 5th, then x equals 5. If log x equals 3, then 10 log x equals 10 to the 3rd.
That is very interesting, Stephen. If we recall our log information that we've learned in the previous time that we've had Mrs. Sloan.
Wow, I can use that now!
Yes, we can! It's amazing! The if and only if, however, wording in this property implies two separate statements. One of them, or b to the x power equals b to the y power, if x equals y, can be used to solve some simple exponential equations by first expressing both sides of the equation in terms of a common base. And we will show that with our next example.
The question, or equation here, 36 to the x plus 1 power equals 6 to the x plus 6 power. Now, if you know your factors, you can tell that 36 is 6 squared. So you distribute that 2 to the rest of the exponent. Power of a power property.
Yes, that is correct, Stephen. Good job. And now we can see here, because of the one-to-one property, basically what it was saying before was, since it is both 6 to a power equals 6 to a power, the powers being these numbers right here, you can cancel out the 6's and make those two powers just equal each other. It's pretty amazing, right, Steve?
Yeah, I know, right? Wow.
Oh.
I wish you could do that in real life. Now we've subtracted x from both sides, giving us x plus 2 equals 6. And then you subtract the 2, and you get x equals 4.
Beautiful. And that is how to solve an exponential equation using a one-to-one property. We are on our way.
Woo! Woo!
So now, Stephen, here's another example of example 1. We can see here 1/2 c. I know, it's pretty impressive. 1/2 to the power of c equals 64 to the 1/2 power. And this is the original equation right here.
How are we gonna solve this one?
Oh, carefully, Stephen. Now, 2 to the negative 1 power equals 1/2. So we can put the 2 in there, and 2 to the 6th power equals 64. So now that sets us up for the power of a power. So now we do 6 times 1/2, which is 3. And this completely sets us up for the one-to-one property, because now they both have 2's. So we just cancel them out. And we have negative c equals 3. And boom, c equals negative 3. Amazing.
Can't believe it. Didn't think we would get through that one alive.
Yeah, the trick is you got to do it carefully.
Yeah, we did it carefully and survived.
Oh, Very carefully.
Now we're on example dos for those Spanish speakers out there.
Ooh.
Okay, we have ln x equals 6. Now there's two methods to solving this equation. In method 1, using exponentiation, you can see that we set both parts of the equation as an exponent to e. Then you can see that the e gets rid of the ln, and it leaves you with x equals e to the 6th. Then you just plug that into a calculator using your E button, and you'll find that x equals 403.43. ln 403.43 into your calculator, and seeing that it equals 6. Method 2. Write in exponential form. ln x equals 6. You can skip the step of eliminating the ln with your e and just writing out that x equals e to the 6th. That is now an exponential form. And you solve using your calculator like I explained before.
Here we are at B.
Thanks, Dave.
We can see 6 plus 2 log 5x equals 18. There's the original equation right there. Now what you need to do is you need to subtract 6 from each side. So you have 2 log 5x equals 12. What you're doing is you're trying to isolate the log 5x. Once again, you divide by 2, as you can see there. You divide it by 2 on each side, so you're going to take out the 2, and you're going to divide 12 by 2, and you get 6. So now you want to write in exponential form, since you isolated it. So you get rid of the log, and you have 10 to the exponent of 6 on the right side. So you have 5x equals 10 to the 6th power. You divide each side by 5, once again isolating the variable. 5 equals 10 to the 6th power divided by 5. Simply plug it into a calculator.
Number C. It's gonna cut out.
I'm leaving that. I'm leaving that in. Number C. Here we are, folks, at number C. Number C.
Letter C. Log of 8x to the 3rd equals 12. We're going to move the 3, that is the exponent of x, over to the other side of log 8x. This is the power property. Now you divide by 3 on both sides, and you get log 8x equals 4. Move them around, because that's what you do with a log. And x equals 8 to the 4th power, or 4096.
Whoa. Look at that. On number C, we got the answer of letter 4096.
Thank you, Jesse, for clarifying Big Steve's mistake.
No problem, Big Steve.
Big Steve loves you too.
Alright, we're back at example 3, solving exponential equations using one-to-one property. For number A here, you can see we have the original equation. Log 4x equals log 4 3 plus log 4x minus 2. Now we use the product property. When a log plus another log of the same base. Now we can see the original equation here. Log 4x equals log 4 3 plus log 4x minus 2. When logs are the same base and they're being added to each other, to one another, you multiply them. So now you can see here 3 times x minus 2, you distribute it, 3x minus 6. Now we can use the one-to-one property. So now we just take out log 4, and we have x equals 3x minus 6. Now we subtract 3x from each side, so we have negative 2x equals negative 6. I suppose I am.
Alright, number B. In order to do this, folks, you need to do this very carefully.
Very careful.
It's the only way. Okay? So, we got log base 3, x squared plus 3 equals log base 3, 52. Because they have the same base, you can use the one-to-one property and set x squared plus 3 equal to 52. Subtract the 3, find the square root, x equals plus or minus 7.
Here we are on number example 4. Right, Big Steve?
Si, senor.
We are going to solve exponential equations now. As we can see, we have 4 to the exponent of x equals 13. You're like, alright, this looks easy. So you take the common log of each side. You give them log 4 to the x equals log 13. And use the power property to bring the x in front of the log 4 equals log 13. And now, x, you're going to divide log by 4 on each side. So you're going to get x equals log 13 over log 4. And each log has a base of 10, as that is the default log base. And that should also be the default on your calculator. So when you plug it in your calculator and you type this in, you should get 1.85.
Number B. For all those folks listening. Still. So we have e to the 4 minus 3x power equals 6. You take the ln of both sides to eliminate the e. And then you're left with 4 minus 3x, which equals the ln of 6. Subtract 4, and then divide by negative 3 on both sides. So you will get x equals 0.74,
Just about.
which you will figure out by using your calculator.
Yes. Remember, folks, we have a log button, an ln button, we have an e button, we have it all.
We're going to solve it algebraically, and then Jesse's going to confirm our answer graphically.
Yes, I will assist you on that. But go ahead, Steven. Tell him how to do it. Tell him how to solve it algebraically.
All right.
Lay it down.
So, we're going to take each side and put ln there. Take the natural logarithm of each side. Okay? Then, we're going to use the power property and move the exponents to the other side of the natural log. Then we distribute, get 3x natural log 4 minus natural log 4 equals 2 natural log 3 minus x natural log 3. Now we isolate the variables on each side. We get 3x natural log 4 plus x natural log 3 equals 2 natural log 3 plus natural log 4. We got that by adding the natural log of 4 to both sides and adding x natural log 3 to both sides. Now, we're going to use the distributive property to realize that we can pull an x out of the left part of the equation, giving us x 3 to natural log 4 plus natural log 3. We use the power property to see that it's x natural log 4 to the third plus natural log 3 equals ln 3 squared plus natural log 4. Okay. Now we use the product property. When two logs are being added together, they're actually multiplied. That gives us x natural log of 3 times 4 to the third equals a natural log of 36. X natural log 192. You divide and isolate the variable, which gives you x equals...
It gives you 0.68. It gives you about 0.68. That's what x equals. Pull out your calculator and you plug in y equals 4 to the 3x minus 1, and y equals 3 to the 2 minus x. This is the original equation right here.
U substitution.
As u represents e to the x. So this u is e to the x, and this u is e to the x. So that cancels, that's what it represents. Now we can factor u plus 8 times u minus 2 is the same as this equation. You plug back in e to the x for u. So now you have e to the x equals a negative 8. Now you have x equals natural log negative 8.
E to the x power equals 2. X equals natural log of 2, or about 0.69. Now, the solution is only x equals natural log of 2, because you cannot take the natural log of a negative number.
The math video? No.